Good afternoon, everybody. I'm Mike Clegg, Dean of the school, and it's my pleasure and honor to welcome you to this very special Dean's Lecture. So my job is not to introduce our speaker, Dr. Klugman, but if any of you speak German, you know what Klugman means, right? It means Klugman is a smart man, and he is, so that's all I'll say about him. But now it's my job to introduce a smart woman, and that's Dr. Kate O'Brien. She's a professor in the Department of International Health and also in pediatrics here at our school, and at the School of Medicine, and she's executive director of the International Vaccine Access Center. She's a pediatric infectious disease specialist from Canada, came to the U.S., trained here in ID and in epidemiology at the school, and has worked on vaccines. So she did a residency and fellowship here in the School of Medicine, and then went to Haiti, where she was conducting research on maternal infant HIV transmission, and then joined the bacterial respiratory disease branch at the CDC as an EIS officer. She came back to Hopkins in 1998 to lead the infectious disease prevention group at the Center for American Indian Health, run by Matthew Santosham, and was conducting clinical trials of vaccines for diseases of importance out on the res. She served as a deputy director for the Gavi Alliance Pneumonia project, and her work domestically and internationally has focused on vaccine-preventable childhood illnesses, including surveillance, epidemiology, and vaccine clinical trials of pneumococcal disease, rotavirus, Haemophilus type B, RSV, and influenza. Kate's worked all over the world. She's worked in Asia, Africa. She partners with local scientists to develop rigorous scientific evidence and bring it to bear on vaccine policy decisions. I can't turn the page, it's stuck. Okay, excuse me. And she's a member, and Kate, as you probably know, is splitting some of her time between Baltimore and Geneva right now. And she's a member of the WHO Strategic Advisory Group of Experts on Immunization, which is the Global Advisory Committee on Use and Policy for Vaccines. Over the course of her career, she's received many awards. I'm just going to tell you a few. The HHS Services Secretary's Distinguished Service Award, given by Donna Shalala for outstanding service in response to the epidemic of acute renal failure from diethylene glycol poisoning in Haiti. The Sabin Young Investigators Award, and the U.S. Presidential Early Career Award in Science and Engineering. It's the highest honor awarded in the U.S. for early and mid-career scientists and engineers. She recently served as the co-chair of the 9th International Symposium, served as the chair as the 9th International Symposium on Pneumococci and pneumococcal diseases, which is a multidisciplinary scientific conference attended by about 1,000 scientists from over 70 countries. And when she was the co-chair, it was held for the first time in Asia, in India. She was named as the Robert Austrian Invited Lecturer, an honor recognizing outstanding contributions to the field of pneumococcal disease control. Kate attended the University of Toronto while receiving a BSc in chemistry, and she earned her MD at McGill University and her MPH here at our school. Please join me in welcoming Kate O'Brien to the podium.
Good afternoon. This is just a huge honor for me to be able to be the person who will introduce Keith Klugman. Many of you in the audience know Keith, and some of you don't. And so I'd like to take a little bit of time to introduce him to you. Keith is a giant in the field of childhood preventable disease in vaccinology, and particularly in the fields of pneumococcus and other pathogens that cause pneumonia. And Keith is presently the director of pneumonia at the Bill and Melinda Gates Foundation, which is an incredibly fitting and important role for him to be playing right now, which is really a leadership role for the global technical community, the policy community, and the implementation community on how we can make traction against the leading killer of pneumonia in the world. But he hasn't always been at the Gates Foundation, and so I would like to tell you a little bit more about his background. Keith attended the University of Witwatersrand in South Africa. He is South African from Johannesburg, where he received a number of his degrees, his Bachelor of Science in Anatomy, an Honors Bachelor of Science in Physiology, and then his medical degree, majoring in Medicine and Physiology, and then went on to complete his specialist training in pathology and microbiology in the UK. He attended Rockefeller University in New York, where he completed some postgraduate microbiology pathogenesis training, and has led major institutions in South Africa over a number of years, and really brought not only the institutions in South Africa, but really throughout Africa to leadership positions. He then joined Emory University, where he was appointed as the William Fagey Chair of Global Health in the Department of Global Health at Emory University, and he continues to hold that chair. He's also a professor of epidemiology and medicine in the Division of Infectious Diseases, and is a visiting scientist with the Centers for Disease Control in the Respiratory Diseases branch. These are sort of titles and roles that he's played, but really I think the most important thing is his incredible scientific contributions that have taught all of us about what pneumonia is really about, what we still don't know, and how we can best make traction in preventing it. And that's manifest in some stunning numbers, which is he has more than 500 scientific publications that have been cited tens of thousands of times. So he really has been a mentor and teacher to everyone in this field. His current position, as I mentioned, really gives him this opportunity to contribute to the mission not only of the Gates Foundation, but the mission that all of us are trying to achieve through the reduction of deaths from pneumonia in children, and in that way, allowing kids to lead really healthy and productive lives. So his expertise is across many domains in the diagnosis and prevention of bacterial respiratory diseases, as well as in the management of the respiratory diseases, and focusing both on bacteria and viruses, including sort of synergies of these organisms together. Keith really is an outstanding scientist, and it's an enormous privilege for our institution to host him here and have the opportunity. Both this morning he was giving grand rounds in the School of Medicine in the Department of Pediatrics, and now this afternoon here at the School of Public Health to talk to us about pneumonia prevention and mortality prevention. So please join me in warmly welcoming Keith to the podium, and we're really looking forward to your talk. Welcome, Keith.
So thanks, Kate, and thanks to the Dean. It's a great honor to come to this extraordinary institution, which really stands at the forefront of science and medicine in the United States. So I'm going to talk about the ways in which we can impact pneumonia and mortality. As Kate pointed out, pneumonia is the #1 cause of death in children, full stop. It's not that in the US, but the total number of kids that die is enormous, and most of those deaths in the developing world, and pneumonia is the #1 cause of those deaths. So before I launch into it, I thought I would pay homage to Bill Fagey. I don't know if any of you guys know Bill Fagey. He was head of the CDC, and he wrote this quite a long time ago now. This is 16 years ago. He's well known for his contributions to the eradication of smallpox. And essentially what he says in this is that although global health has improved dramatically, and the Dean and I were just congratulating each other on how global health has really expanded and captured the imagination of medical schools and students throughout the US, the point he makes here is that the gaps between the rich and the poor remain vast. So that's the backdrop for what we're going to talk about. And so there's an overarching mission at the Gates Foundation that every person deserves the chance to live a healthy and productive life. It's kind of a nice way of putting it, because the foundation's mission is not talking about death. But when I had to figure out, well, what do we do in the pneumonia field, our contribution to allowing every person to live a healthy and productive life is to reduce deaths from pneumonia. And our focus is in children. There is a major cause of death from pneumonia in adults. At the moment, we're focused on the kids. So where's the problem? Well, the problem is in the developing world. I say that it's the #1 killer of kids under 5. And the geographies that have been highlighted here, unfortunately, contribute around 50% of all of those deaths. So just 6 countries. 3 in Asia, 3 in Africa. It's India, Pakistan, and Bangladesh. And then Ethiopia, the DRC, and Nigeria in Africa. And these are countries that not only have a high burden of disease, but have an enormous number of children, and that's the reason that they contribute so much. So there are a number of studies like this. I've chosen 2. This one's from a while ago, and what it does, on the x-axis, you're looking at the mortality per 1,000 kids per year. So that's the infant mortality rate, and obviously, towards the right-hand side of the slide are the areas of the world that have the highest infant mortality. And it's looking at the contribution of pneumonia to that mortality. And you'll see that the percentage of deaths due to ARI. ARI is an acronym which I don't particularly like. It stands for acute respiratory infections. I think it was a sop to the influenza folk to include influenza in pneumonia deaths. But essentially, if you die of an acute respiratory infection, you die of pneumonia. So these are pneumonia deaths. And what it's showing is that as the infant mortality rate goes up, the fraction of that mortality that is attributable to pneumonia goes up too. So if you're in the US where the infant mortality rate's like below 5, your fraction of that mortality that's attributable to pneumonia will also be very, very small. Now, this isn't true only of pneumonia, it's true of diarrhea too. So here's a more recent study, and unfortunately the axes are switched around. So at some point I might have to fix it if I want to show the slide again. But now we've got the infant mortality rate on the y-axis, and the percentage of under 5 deaths caused by pneumonia or diarrhea. And you'll remember the other slide plateaued at around 20%. This is plateauing around 35 to 40%. So really the same for diarrhea and pneumonia. The deaths occur where most kids die. Now, this is a study I really like. I don't know if it's true or not, but it shows a pretty picture. And it's a picture of one country. It happens to be India. And you won't be able to see the details at the bottom, but if you're in Shanghai or Beijing, infant mortality is 4 to 6 per 1,000. So that's the number of kids who die per 1,000 live births. And that's the same as the US. And there's everything's up to 100%. So of those, this is the pneumonia fraction over here. So you see the tiny fraction of deaths in the parts of China which have the lowest mortality. Here are the parts of China that have the highest mortality, and here we're up to 38 deaths per 1,000 live births, whereas it was 5 down here. And if you follow this line of the sort of turquoise or whatever color it is, you can see how it expands. Eventually, it's the #1 cause of the highest mortality region. So the expansion of pneumonia as a cause of death as you go from low to high mortality in China. So now I'm going to share with you some data generated right here in this institution, and in fact they were only published online this week. So this is hot off the press, the CHIRG data, which look at the causes of death in kids. And here's the pneumonia part of the pie, which is 15%. So it remains the #1 cause of death in kids, but it is up there with preterm complications at 15%. The important aspect of this, which I'm going to talk about in the second half of my presentation, is this huge contribution of neonatal deaths. So this was under 40% the last time it was looked at a couple of years ago. and it's now 44% of all deaths are in neonates. Now, that's an extraordinary number because we're looking at deaths in the first 5 years of life. And the way I like to think about it is there's 60 months in the first 5 years of life. And this is telling you that 44% of all the deaths are in one of those months. And it happens to be the very first month. And in fact, a large fraction of these neonatal deaths are in the first day. So an awful lot of the mortality is very, very early. But the extraordinary interventions which I'm going to talk about, which have reduced pneumonia deaths, we believe, particularly vaccines, have had no impact on neonatal mortality. And so we are focused now on ways that we could reduce the neonatal deaths, but I'll talk about that in the second half of my talk. So if we look at the same data, so we played a bit around with the data. There is an online appendix which includes a spreadsheet. And you can begin to look at the things you're interested in. So this is India at the top here. And so India remains the number, and this is death from pneumonia. Sorry, the acronym pneumo in our world is pneumonia. So these are pneumonia deaths, and it's the rank by year. And you see that India is number one, remains number one. But there are one or two things on this that I thought were really quite interesting. So this is looking at sequential studies that they've done over time in the last 15 years or so. And you see this one going down. Now that's China. So from number 2, China is now slipping down the ladder, which of course, if you're on a ladder of death, is a wonderful thing to come down. There's another one that is going down here, and that's the green line, Bangladesh. And when you visit Bangladesh, you see the remarkable changes that have happened there and how Bangladesh mortality is not going up. The two that are going up, unfortunately, are both in Africa. And this, I believe, is DRC. And there was another one going up in Africa at the bottom here, Angola. So that's all interesting, but there's something quite controversial in these data that I couldn't help talking to, and that is that if you do the same thing and you look at deaths from pneumonia then in India over the last 5 years, although it remains number one, there it is number one, the deaths have halved. And India is a place where we have really struggled to get these life-saving vaccines. Both the Haemophilus influenzae type B disease vaccine has hardly rolled out in India. It's in a couple of states. The pneumococcal vaccine isn't there yet. So why on earth has pneumonia mortality halved in India? Well, in general terms, you could say it's a reflection of improved access to care, transformation of the extreme poverty that's reducing. But when I looked at that line going down, it reminded me of another line that I've seen in a graph going up over pretty much the same period, at least from 2005, in the middle of this line going down, and it's this line. This is antibiotic consumption in India between 2005 and 2009. And some of the big mortality states, this is Bihar over here, and there was another, this is Uttar Pradesh over here, and this is Bihar in the orange. So what's going up, in fact, is largely widespread access to cephalosporins. When you go, as I have done, to the rural parts of India, rural parts of Bihar, there are people selling antibiotics everywhere. They've always been there, always. You know, certainly in the last 15 years, they've been there and they've had antibiotics. The difference is that people couldn't afford them. And now people can afford those antibiotics because they're very inexpensive. And I think it's at least an idea. I'll be interested to see what Matu thinks about it. But this, if you think about the fundamental premise, why don't kids die of pneumonia in the United States, for instance? It's because we have rapid access to care and abundant access to antibiotics. So I actually think there may be some plausibility in that reduction even prior to the introduction of the vaccines. Now here's some data. Not all the data I'm going to show are from the Hopkins School, but I thought I would share a few slides from folk in the room. So this is a very nice study that Kate was the lead on. Switching now from pneumonia to the leading cause of death from pneumonia, which is the pneumococcus. And the size of the pie here is a reflection of the burden of disease. And there again, for the pneumococcus, India was number one. You see, China, in fact, although it has a low rate of disease, has so many kids that the pie is quite big. But these are the places that have the biggest burden of mortality, and they happen to be exactly the same places that I pointed out in the first slide are the focus of our attention in the Gates Foundation. So to prevent mortality from pneumonia, we're doing a number of things. They're listed there. I'm not going to go through them in great detail because I'm going to talk about them now. So this talk is all about reducing mortality, and it's actually extraordinary that in one of the pneumococcal vaccine trials, there was actually an impact on mortality demonstrated within the trial. It's quite unusual in a double-blind randomized trial to have a mortality outcome, but this was a trial of a 9-valent pneumococcal conjugate vaccine. So a vaccine prevents 9 strains of pneumococci, and it was given against a placebo. There are the numbers of kids in each group, and you'll see that there was a very high mortality rate. You're only immunizing 8,000 kids, and 330 kids are dead by the end of 2 years into the trial. I mean, it's a shocking number. But in the control group, it was 389, and that's a 16% reduction in mortality, which was significant even within the context of the trial. So we have direct evidence from a vaccine trial that the vaccine can prevent mortality from pneumonia, but we have a bunch of additional evidence too, which I'll just share with you, which is observational. So this slide I showed this morning briefly as well, but it's one of my favorite slides, and in fact, Pilishvili is the first author, my last PhD student at Emory. And so these are data generated by the CDC and looking at the burden of the vaccine types included in the 7-valent vaccine prior to the introduction of the vaccine in the year 2000. And you see in the first year, the numbers dropped dramatically because the vaccine was introduced in January. So the total of cases by the end of the year was already down, and then it continued to drop, and it's essentially zero. I don't know if you can read the red that well, but that says 100% reduction in those vaccine types. Now, there's quite a lot of story to this, so I'm not going to go into detail about replacement and so on. But the reason that I wanted to show it as an introduction is that the impact of this vaccine on mortality is not only in children, it's in adults as well. And so to explain that, you have to say that does the vaccine impact pneumococcal disease in adults? And it does. So this is the same vaccine types that are in the pediatric vaccine, just the 7-valent types. And you'll see in adults, by 2007, they were down 92%. Hasn't been published, but by 2012, it's more than 99% reduction. So the disease goes away in kids and in adults, and the studies I'm going to share with you on mortality show that, in fact, the mortality benefit is also in the adults. There are very few data from the developing world on this question of direct or indirect protection. There's some data. This is direct protection, so this is kids, and it's in Kenya, and this is the number of kids that got pneumococcal disease before the vaccine was introduced. It's tricky at that site. It's a small site, and there's a lot of variance in the number of cases, and it's to do with epidemics of type 1. But very quickly after the introduction, they only had 4 cases. So that at least is promising. And I'll share with you these data. They're actually going to be published in the New England Journal in the next month or so, or an updated version of this will be published. But it's the introduction of the vaccine in South Africa. And this is not just the vaccine types. It's all types of pneumococci. So you see what you would hope to see in the kids, a reduction, which is going down. And this is 1 to 4 years of age. So the kids, the older kids now are getting the vaccine. It was originally introduced in 2009. But look at these older age groups that never got the vaccine, including this age group, which is the HIV-infected adults who get pneumococcal disease. So in most parts of the world, you get a U-shaped curve for pneumococcal disease. We don't have an awful burden of pneumococcal disease, interestingly enough, in the elderly. but it's about equivalent across everybody from age 25 up, and that's a reflection of HIV, but you see these reductions. So we're confident that there is herd protection also in Africa. Now, that's all invasive disease, which is easy to measure and important because you can actually tease out the fraction of kids who got the pneumococcal vaccine because it's only certain types. But there's a wealth of data now from around the world on pneumonia. So these are all double-blind randomized trials which had X-ray confirmed pneumonia as an endpoint. And they use a variety of vaccines, and there's truly now a global distribution of these studies, although you could say there's only been one study in Asia. And broadly, I'm not going to go through all the data, they show fairly similar data. So between about 20 and 40% reduction in X-ray confirmed pneumonia in children. But you can use databases in the developed world like the US to begin to tease this out further. So this is a picture of hospitalized kids in the United States, and this is interrogating databases of hospitalization. So with hundreds of thousands of hospitalized individuals. And this is the reduction that the CDC saw in invasive pneumococcal disease. But here is the reduction in pneumococcal pneumonia in kids. And what you find when you look at those databases is not quite the same slope, but a more gentle slope, but a reduction in invasive disease and pneumonia in adults too. And when you begin to count up the cases, you get some big surprises. Because I told you earlier that in the United States, not a lot of kids are hospitalized with pneumonia. And so if you look at the total number of invasive pneumococcal disease cases prevented, in kids less than 2, it's not trivial, it's about 8,000. But in adults, in red here, is a bunch more. And in fact, 75% of the invasive pneumococcal disease hospitalization prevented is in adults. If you move to this, which is lobar pneumonia, the hospitalization prevented due to X-ray confirmed pneumonia in the United States is 95% in adults. So we introduced a vaccine to protect kids from pneumonia in the United States, and 95% of the benefit is actually in adults. Well, that's great, but it's not proven as yet for the developing world, but certainly an extraordinary reduction. This is actually looking at deaths, and again, I'm just highlighting here. If you look at, say, deaths, estimated all-cause pneumonia reduction, this is mortality. You'll see that's the estimate of the number of kids with pneumonia, the mortality in kids that's been reduced in the US, and that's the estimate of the over 5s. So it's really an extraordinary impact in the elderly. Now, this is a picture from Denmark, recently published data, again looking at all ages. I'll just show you, here's the dramatic reduction in disease when the vaccine was introduced in the kids, and then B. So A is less than 2, B is over the age of 65. The same, more gradual effect, but wonderful herd protection. And this is a different vaccine schedule, only 3 doses altogether, whereas in the US we use 4. And if you look at their estimates of pneumococcal mortality, the best line to look at here, this is the mortality rate reduction. So there's been an 81% reduction, there's odd ratio 0.19, so 81% reduction in pneumococcal mortality in kids less than 2, and it's significant in virtually all age groups. So reductions in pneumococcal mortality across all age groups, and because the numbers are so much higher in the adults, they're almost certainly seeing the same thing. Now, that was all post in the US PCV7. We've looked at the new pneumococcal vaccine, which is the 13-valent, and again, we're seeing the same thing. These are the reductions across all ages, and we're seeing them quicker now because there was a catch-up in the US. So more kids under the age of 5 were immunized when this vaccine was rolled out, and we believe that that's led to very rapid herd protection. So the answer here is that we do have an intervention to reduce pneumococcal pneumonia and pneumococcal pneumonia deaths in children, and that by an extraordinary attribute of the vaccine, that it interrupts transmission, so the strains no longer circulate in the community, you also protect adults from pneumonia deaths. And here's some data. This is these sorts of observational studies, you have to be careful. You can't necessarily attribute them directly to your intervention, but this is a recently published study from Nicaragua, which is also showing a dramatic reduction, in fact, in this case, in all-cause mortality, which they're attributing to the pneumococcus. I'm not entirely sure that all of that attribution is correct, but it's at least a trend in the right direction. And if you look, you see these spikes in mortality, which would be the winter mortality, and then after the introduction of the vaccine, both in infants and 1-year-olds, you no longer see those spikes in mortality. So that certainly suggests it's a respiratory winter pathogen that's being protected against. So now I want to come to the second half of my talk, which is after celebrating these reductions in mortality, and this is another picture of infant mortality going down in the world, and there's the Millennium Development Goal. Here's the bad news, that although mortality has been reducing a little bit in neonates, it's nothing like the slope of the reduction in the older age group. So is it possible to introduce vaccines which could reduce mortality in neonates in that first month of life? And so we come to maternal immunization. And so the idea would be it's possible theoretically to immunize kids at birth, but they have to make an immune response. The immune system is very immature at birth. And the option to try and protect kids from mortality, because many of these deaths in the first day or two, is just not going to work to immunize the newborn baby. But you can immunize the mom. So what do we know about maternal immunization? So this is our strategy. There are 5 pathogens up here that we believe not only cause mortality in the first 3 or 4 months of life, but are amenable, we believe, to a vaccine. There are other causes. There's gram-negative sepsis, where at the moment we don't have a vaccine which could impact it. We don't have vaccines for all of these. We have vaccines for 3 of the 5. So influenza, I'll talk about a little bit more. There's some big studies that we funded at the foundation, the first of which is just presented its data, and I'll share it with you. RSV is the number 1 cause of mortality, we believe, in young kids in the first 3 months of life from pneumonia. And we don't have a vaccine, so we have to make one. So we've got some cool ideas about how to make one, and I'll share them with you. Pertussis, the pertussis programs have been focused on immunizing kids early. So in developing countries, the vaccines roll out at 6, 10, and 14 weeks rather than 2, 4, 6 months in the US. And that early rollout is to try and prevent these pertussis deaths. But most pertussis deaths now are in unimmunized kids too young to be immunized. And again, you could protect kids by vaccinating mothers. Group B strep, we don't have a vaccine, but it's an encapsulated organism. So as a capsule, like Hib, like meningococcus, like pneumococcus, we could make a conjugate vaccine, and when I say we could make, at the foundation, we don't make anything. We just give money to other people to do good things. So we're going to give money to people to make a Group B strep vaccine. And then tetanus, there has been a program in developing countries, and we can look to see how that program fits into an antenatal program for maternal immunization. So when it comes to pertussis, unfortunately, very few people do PCR to measure pertussis in the developing world, and we are funding a very big program here, the PERCH study, which is doing just that. But for the time being, we don't have good data on pertussis, certainly not pertussis deaths from outside the developed world. Well, these are pertussis deaths in the US, and it's not an awful number. It's up to about 30 kids a year. But why I'm showing it is I want to show you the age of the kids. So if you look for the blue color here, it's less than 3 months. And you'll see what fraction, you don't have to do statistics on this, to know that 90% or more of all pertussis deaths is in the first 3 months of life. And so therefore it's amenable to an intervention like a maternal vaccine. And in fact, the ACIP that makes recommendations in the absence of any evidence has made the recommendation that pregnant women get a pertussis vaccine. And in fact, there's a case control study that has just been published in the Lancet from the UK, which also did this, and it showed a 91% reduction in early pertussis cases in the UK. So that's exciting. What about Group B strep? Well, again, there are some data I'll share with you in the next slide from Africa. But if we look at the US, and we're looking here at meningitis, this is a nice study from the CDC looking at meningitis by age, and that is Group B strep, this light yellow color. So totally dominant in the first 2 months of life, which is when we could introduce a vaccine. And that's despite the fact that most early onset Group B strep disease has been eradicated by antibiotics. So back to antibiotics. These are the data from Africa, and the burden of disease data are bigger than for Europe or for the US. So we believe that there's a significant burden of disease in Africa. There are big questions about the burden of disease in Asia. So our program for Group B strep will be focused, at least initially, on Africa, developing a conjugate vaccine and rolling it out to pregnant women. There's a lot of stuff on the slide about why maternal influenza immunization. Essentially, we don't have a vaccine to protect kids up to 6 months of age from influenza. There are 2 vaccines for influenza. Hopefully, you've all had one of them this year, and that's the 2 vaccines are the killed vaccine, which is indicated from 6 months of age, and then the live attenuated influenza vaccine, which is probably a better vaccine for kids, but it can't be given under 2 years of age. So between 0 and 6 months of age, there's nothing. And so therefore we were interested in maternal immunization. There are lots of issues around it because the vaccine is not widely available in the developing world, has to be given every year. But what are the data? So here are some data published just last month, in the New England Journal of the first of 3 trials. So we funded trials in South Africa, Mali, and Nepal, and in fact there are Hopkins investigators involved in the Nepal study and maybe even in the Mali study, I'm not sure. But these are the first data to be published, and they show quite a lot of interesting things. So this is a blow up of this percentage here. That's 25%, 50%. So this is the attack rate of influenza. This is PCR confirmed influenza in the placebo group. And what we're looking at here on the left-hand side is the mothers. And these are HIV uninfected mothers. And you'll see that about 5% of the mothers during pregnancy had PCR confirmed influenza. And if they were vaccinated, this is the vaccine group, it drops by about half. And it's about what influenza vaccines do. They're not great, they're 50% protective. If you look at the HIV-infected mothers, there's a surprise, and it doesn't look that obvious, but there's no insert here. 25% of HIV-infected mothers had PCR-confirmed influenza during their pregnancy. And I just told you that the number is less than 5% in HIV-uninfected pregnant women. So we knew that there was an increased risk of influenza in pregnancy. What we didn't know was that HIV greatly amplifies that risk. And so this is something totally not discussed up until the release of these data. The burden of influenza on pregnancy in HIV-infected women. And quite surprisingly, the vaccine was efficacious. In fact, there's a 70% reduction. Now, the numbers here are tiny. If you look along the bottom, this wasn't a study that was designed to show efficacy in HIV-infected women. It was, the efficacy trial was up here in HIV-uninfected women. The HIV-infected women were enrolled in a separate small immunogenicity study to see whether the vaccine was even immunogenic. But we got as many cases of influenza in the 100 HIV-infected women as we did in the nearly 2,000, well, it's 200 versus 2,000 HIV-uninfected women. The kids, well, what happened in the kids in the first 6 months of life? And you'll see, in fact, there is a separation here. It is significant. There was a similar 50% reduction in influenza in the kids of the HIV-infected uninfected women. These kids here are also HIV uninfected, thank goodness. We had no vertical transmission of HIV in the 200 women in that trial. But the numbers are too small here. As I said, it wasn't powered to pick up an impact of of influenza in HIV uninfected infants or adults. They just saw the impact in the parents. What about RSV? When do kids with RSV die? Well, it turns out, again, we have very little info. So all of this is unpublished. And these data we've got from Argentina and South Africa. Again, this is an area where I think the PERCH study will tell us a lot. But it's looking at the timing of mortality of kids who die in the first year of life from RSV. And the numbers are not huge, but in the first Argentina study, there were 11 deaths, and 73% of them were in the first 3 months. All of the deaths were in the first 6 months. A larger study, also unpublished, 56 deaths from proven RSV, and a little bit less percentage, but still a significant fraction, more than half in the first 6 months. These are some data from South Africa. So the numbers at the bottom, 41% of these 3 cohorts of kids who died of RSV died in the first 3 months, and 72% in the first 6 months. So again, we think that a maternal vaccine will play a role. It's not the vaccine that's going to prevent all RSV mortality. We need RSV vaccines for infants, but our initial focus is going to be on pregnant women. And this is virtually my last slide. What are we going to do because we don't have an RSV vaccine? Well, it turns out we do have a monoclonal antibody that protects infants from RSV. And that monoclonal antibody has monoclonals to this protein, the F protein. And so we're now thinking, well, if the F protein given as a monoclonal antibody protects young infants, why can't we give F protein to their pregnant moms, let mom make the antibodies and transfer the antibodies naturally to the infant? And so that's essentially what's on here. And we're now funding the first study of F protein immunization of pregnant women right here in the United States, and the first woman was enrolled about 2 weeks ago. So in summary then, deaths are declining in children, and this is really good news. The burden of mortality in children, the total number of kids that die has dramatically reduced. It was around 20 million deaths, we believe, as recently as 1990, and that's now way down. Well, it's still a large number of deaths, between 6 and 7 million now. But pneumonia remains a major killer of both children and adults. Pneumococcal conjugate vaccine is rolled out in many developing countries where it is reducing mortality, and I showed you some of those data. Protection extends to young adults with HIV, these are the data from South Africa, and to the elderly through herd effects, and I showed you the US data on that. More than 40% of childhood deaths occur in neonates, the latest CHIRG data are 44%, and neonatal mortality has reduced to a lesser extent. Maternal immunization has the potential to reduce neonatal mortality and to increase the benefits offered to mothers as part of antenatal care. And so that'll be the focus of our attention in the next few years. So thank you for your attention.
Keith, thank you so much. I wonder if we can get the microphones turned on the side. So I think we have some time for questions. And what I would ask, rather than moving microphones around the room, which takes time, if people could, there are microphones on either side. If you could just come up to the microphone and ask your question, we do have some time.
Great.
So Keith, that was an excellent talk as usual. So if I may challenge you on
Yes, on the India mortality.
the antibiotic theory. If you go back to the early 1900s, before antibiotics were available, if you look at infant mortality from 1900 down to going all the way down to 60s, the steepest drop is before anything was available. No antibiotics, no vaccines. So I'm just wondering, but I really don't understand what drops mortality. And there's obviously a whole bunch of things happened during that time, water and sanitation, nutrition. I think we all want a simplistic explanation as to why. First of all, I don't believe, I told Bob Black this when we were on vacation together, I don't believe his data. I don't think that the pneumonia mortality has dropped that dramatically.
Right.
I think there are a lot of assumptions made, a lot goes into those models.
Right.
So, but there's no question it is dropping. But I also found that it just, of my, and I don't have data to challenge you, but the antibiotic usage has not changed that dramatically. People are using lots of antibiotics for the last 5 years.
Yeah, I mean, I don't know, but I think, well, it's two things. One is I agree with you that the impact on pneumonia mortality, which predated the introduction of antibiotics in the 1950s, was almost certainly related to sanitation. And in fact, there are still data to this day from one part of the US which has sanitation issues, which is Alaska, which showed a dramatic impact, or at least a risk for pneumococcal disease was lack of provision of clean water. So I think that does play a role. I think we need, obviously, that we need more data on this. The issue, one of the correlates of antibiotic use for the pneumococcus, unfortunately, is resistance. And in India, despite the widespread availability of antibiotics, it has always been extraordinary that antibiotic resistance was at a very, very low rate for many, many years. And I believe that's now changing, and that resistance is beginning to shoot up. And I have always believed that despite the availability of antibiotics, the vast majority of people simply couldn't afford them, or could only afford perhaps one pill or something like that, and that's what, it wasn't enough to drive resistance. So I think we'll actually be able to tell. I mean, the one way to look at it, if there has been a dramatic increase in antibiotic resistance in the pneumococcus, that could be a correlate of increased exposure of the bug to the antibiotics. And where I have been perhaps a little outlier in the pneumococcal world, or in the pneumonia world, is I actually don't believe that the pneumococcus causes 50% of pneumonia mortality. I think it causes 80% of pneumonia mortality. And so I think that it's a pretty good surrogate for what's going on in pneumonia mortality. So yeah, I mean, I think it's fascinating. So I certainly have no insight into those numbers. I just saw them and thought, well, is there any explanation I could come up with?
Keith, I have a question for you. On the RSV side, you finished by talking about development of a vaccine. I think we can all agree that the RSV vaccine field is a graveyard of products that have failed. So although we're all glass half full people, what you didn't talk about is the potential for the use of monoclonal antibody in a limited number of doses, in limited settings, to at least address some of this very early mortality. Where do you think that fits, if at all, and what would be the barriers to moving forward on it?
So a good question, Kate. And so when I arrived at the foundation, people were lining up to get me to fund their projects, and one of which was WHO saying, well, these monoclonals may cost hundreds of dollars or thousands of dollars, but we could probably get them down to hundreds or tens of dollars. And can't the foundation fund that? And my problem is that we can't get access to these kids who die in the developing world to give them 3 shots of a vaccine, never mind find them to give them an intramuscular injection monthly for 3 months to protect against just one pathogen. So I was underwhelmed by the notion. But I'm not sure if I'm allowed to talk about this, but let's just say that if theoretically there were to be a monoclonal antibody which had a half-life of 3 to 4 months rather than 20 days, then such an antibody, if it were given to infants at birth, might be really interesting. And so we would be interested in looking at such an antibody if it existed.
And Lou is here somewhere. Lee, do you want to, there were obviously some questions about your paper and the reduction in pneumonia. I just wanted to invite you.
That's great.
If you wanted to come up and address them.
I didn't quite get what Chi was asking, but I think it was on Indian pneumonia estimates, right? So
He was arguing that the reduction can't be due to antibiotics. Reduction in
I was also arguing about the whole time that the numbers and stuff.
So I was defending your numbers and giving you an explanation of what they could be.
Yeah, a great answer for that question. So just, based on the paper that, Keith has presented and we actually worked on, we actually only produced and worked on those estimates. We didn't really look into why pneumonia estimates actually reduced in India. And, the same as you, I think we haven't looked into this data. There's no way we can actually draw definitive conclusions in terms of what has changed. But, from the last paper, which was published in 2012, there was a pretty substantial reduction in diarrhea across the board for all countries. And there were a lot of speculations about, what had happened, including improvement of water and sanitation. So I don't know, maybe, we should be doing a lift exercise or, conduct other studies, or maybe the Gates Foundation should be funding a study actually to look further into this. Exactly,
The
yeah.
dean likes that thought, yeah.
Yeah. Someone needs to work on that.
Okay. Interesting, yeah.
So it's so nice to see a talk that's data-driven, that drives strategy. So I really enjoyed the talk. And I knew this, but I was, you pointed out, I'm surprised we don't have a vaccine against Group B strep. And so let me ask you, as I'm a non-ID person, how come? It's got a lot of burden of disease.
Sure.
We've recognized it for a long time.
It sat on the shelf of a number of companies, I believe, for a good many years, and the problem has been that the only way to deliver it is in the setting of maternal immunization, and the big pharmaceutical companies have been risk averse, and there are a number of issues that need to be resolved. One is that we have a Vaccine Safety Act for vaccines that are given to children in the US, which indemnifies companies from lawsuits. And there's uncertainty as to whether a vaccine given to a pregnant woman specifically to protect her unborn baby is a vaccine given to children, and therefore whether such a vaccine would be covered by the Act. And that is something that is, there are equivocal results in lawsuits and so on at the moment, but that's been an impediment in the field. What changed the field dramatically was the 2009 influenza pandemic, when it was recognized that pregnant women were a particular risk for mortality, and there was a lot of press around it and a lot of advocacy from physicians to vaccinate pregnant women for the first time, and so now we have around 50% of pregnant women get the flu vaccine, and I think that was the game changer. And that led then very quickly to the recommendation with the outbreaks now of pertussis. The pertussis is going up in the US. That led to the indication for pregnant women to get pertussis vaccine. And I think that that's been the game changer. Now, Novartis have started development on a Group B strep conjugate vaccine, but they've just been sold to GSK. So we don't know whether that vaccine is going to go forward. We hope it may, but we're in the process of trying to identify a developing country manufacturer to make such a vaccine. And I'm in the same boat as you are. I mean, I find it extraordinary that we don't have a vaccine when this is an encapsulated organism, and the proof of principle is there. There are people like Carol Baker, who's worked for many, many years, folk up at Harvard too, worked to make the case. There's certainly plenty of animal data suggesting you can protect, and there's even one study in women showing a small impact on acquisition when they received the vaccine, but that's never been published. It was only presented. So we've got a ways to go. One of the other issues is the size of the trial that you'd have to do. If you want to do such a trial in the US, where virtually all of the early onset Group B strep has been dealt with, you're only dealing with late onset disease, and you'd need hundreds of thousands of women to be randomized. So the studies really need to be done in the developing world, and so therefore there's also a question of the appetite of risk of big pharma to do such studies.
Thanks for a great talk, Keith.
Sure.
I was
I think we've all seen alternative versions of the burden of disease graph where you can see underlying disease, particularly malnutrition, contributing to something like 50% of the overall causes of mortality. And so I'm wondering, you know, certainly some of the things that can be contributing to the reduced burden would be improvements in malnutrition or
Absolutely.
reductions in HIV. We know that malnutrition and HIV are certainly huge risk factors for death in pneumonia cases. And I'm wondering what, obviously the foundation's, you know, made huge investments in a wide variety of areas, but I'm wondering how the foundation approaches looking at these risk factors in pneumonia, and is that something the pneumonia team works on, or how does the foundation approach that, and investments in health systems that may result in,
Okay,
in these?
so super question, Laura. So absolutely, we did a very small pilot in our vaccine trial. Well, we just did an observational study within the trial to see what the risk factors were for mortality, and malnutrition came out as an overwhelming risk for mortality. And I know that within Perch they've looked at that algorithm, and it seems to be predictive right across the Perch sites. So yeah, I mean, so Matu, I think that's another thing, but of course we would need the evidence that there's been this dramatic impact on malnutrition in India over the last 10 years, and I don't know if it's there, but if it is, that would certainly be a big driver of reducing pneumonia mortality. To your specific question, it's a risk factor. We do have a bucket which is for risk factors, and I think that malnutrition is the most important part of that bucket, and we do have within the foundation a nutrition cross-cutting group who have tended to focus on stunting and long-term malnutrition issues. We're talking as a risk for pneumonia really in acute malnutrition, and I am very interested in it. So we are going to be funding studies, and we're trying to figure out how best to address this. We're probably going to focus on, is there something that you can do directly to reduce the mortality of malnourished kids? In other words, there's a treatment intervention, which may be nutrition-based, that could reduce that mortality, or is it too late? If it is too late to intervene when the kid already has the pneumonia, then it would be great if we could partner with our nutrition folk to try and figure out some pneumonia endpoints for the nutrition studies. But I agree that malnutrition is a huge driver of pneumonia mortality.
So I think we're going to wrap the questions up at this point and turn it back over to the Dean.
I have to say, I admire the Gates Foundation a great deal, and they've done a lot for children and people around the world. But I feel much better about them now that I know that you're there, because this was such a clear exposition of what we know, what we don't know, and where we need to go. So I want to thank you. It was a great talk, Keith, and you can count on us to partner in any way possible to move this mission forward.
Thank you.
Thank you very
I
much.
appreciate it. Thank you. Thank you.